In this lecture, we are going to use reduction potentials to actually predict whether or not a redox reaction will occur spontaneously. So in general, a spontaneous reaction will take place when a reduction half reaction is paired with an oxidation half reaction that's lower on the table or has a lower or more negative standard reduction potential. Let's look at our copper and zinc example. It's kind of our go-to. So pulling those standard reduction potential values off of our chart, we know that the copper reduction has a potential of plus 0.34, and our zinc reduction potential has a value of negative 0.76. So when we pair the reduction of copper with a value that's more negative, so our zinc, then we'll have a spontaneous reaction. What will happen in this case is we'll have our zinc or zinc, sorry. So this is the reduction, right? So the oxidation potential will be plus 0.76. So that zinc is going to be oxidized to our zinc plus 2, and our copper with the more positive value for our reduction potential is going to be reduced to copper metal. And that'll happen spontaneously. Now, if we were to switch it, if we were to make the zinc be reduced and the copper be oxidized, we would see a cell potential that would be equal to our, so our cathodes where reduction's happening, and so we're saying zinc will be reduced instead. So it'll be the negative 0.76 volts minus our positive 0.34 volts, which is going to give us a value of, let's see, negative 0.42 volts, which is not a positive number. And so these negative cell potentials, if we get a negative value overall, is going to correspond with a non-spontaneous process when it's negative. So we can use that kind of shortcut of just looking at the table and saying, well, anything below this will be able to be oxidized by this as the one we're viewing is reduced. So let's predict if this reaction, this redox reaction, is spontaneous under standard conditions. We've got our iron becoming iron plus 2. So we're losing electrons, so that's being oxidized. We have our magnesium going from plus 2 to its elemental form, so it's gaining electrons, so it's being reduced. I've pulled those reduction half potentials off of our table for you here. So our magnesium is a more negative value than our iron reduction potential. So that would mean that our iron redox potential, or sorry, our iron oxidation potential is really like plus 0.447. So just looking at where the magnesium falls, it's not being, it's being reduced, but it's more negative. So than our iron. And so this is not going to spontaneously occur. Let's double check it by calculating it though. So our cell potential is going to be equal again to our cathode reduction potential minus our anode. And our anode is where things are being oxidized, and our cathode is where they're being reduced. So we're saying here that our iron is being oxidized at our anode and our magnesium is being reduced at our cathode. So the cell potential is going to be that negative 2.372 volts minus our reduction potential for our iron, which is that negative 0.447. This is going to give us a value of negative 1.92 volts. So this is a negative value. It's going to be non-spontaneous. So I don't expect our iron to be oxidized while our manganese is being reduced. Instead, I would expect the opposite. I would expect our manganese to be oxidized while our iron is reduced, so that manganese would act as a reducing agent rather than an oxidizing agent. Let's look at another example of this and think about it a little bit differently. So here I have a set of materials. I've got fluorine, iodine, iodide and iodine, and then chromium ions. Um, and the question is, which of the following materials will oxidize our copper without oxidizing our silver? So let's highlight these. Here's our silver, and here's our copper. And so we want to oxidize these. So they're going to be acting as the reducing agent. And the question is, which of these materials here will be reduced? While oxidizing copper, but not silver. And so this is thinking about it a little bit differently than we did before. Before we said that spontaneous reaction will occur when a reduction is paired with a oxidation reaction that is lower on the table than it. And so now we're looking at an oxidation reaction of copper or an oxidation reaction of silver. And we want to know, what reduction do we pair it with? And so looking at this, that means that our reduction is always going to be higher on the table if it's going to be spontaneous. So if we're looking at these as oxidations, what is above copper but not above silver on our reduction half reaction table? Because that is the element that will be able to oxidize copper but not our silver. And there's only one option that falls in between the two. It's this iodine forming iodide. Right here, C. And so that's the only one that can actually do the job of oxidizing copper. I mean, silver can oxidize copper, so can iodide and also fluorine. But the iodide and the fluorine will also oxidize the silver.